I missed all, but that's okay. All right, so, oh, I don't want to record. I want to take roll. Okay, so now we're doing a ratio test on this. I need somebody to tell me what AN plus 1 looks like. No takers.
I think I can try.
Okay,
Okay, so on the top is gonna be 2 times n plus 1 factorial.
2 times, good, n plus 1 factorial. Okay, and on the bottom,
And for the bottom, can we use squared?
yeah, you can.
It's just like n plus 1 squared factorial.
Okay, that it is not.
No.
No, it is not n plus 1 squared factorial. It is n plus 1 factorial squared. There's a difference.
Okay.
Okay. All right. But that looks really good. Okay, thank you. Okay, so now I need to compute the absolute value of AN plus 1 divided by AN. So AN is, I don't need absolute values. Everything's positive. So I get, that looks like 2n plus 2 factorial over n plus 1 factorial, n plus 1 factorial. And then when I divide by AN, I get n factorial over 2n factorial. So that's what we get. All right, so this, I'm now going to put the 2n plus 2 factorial over top of the 2n factorial. Zoom is really giving me grief these days. I don't know why. Okay, then I have n factorial. I'm going to put it over one of the n plus 1 factorials. And then I have n factorial. And I'm going to put it over, so I have n factorial, and I'm going to put it over n plus 1 factorial. Okay, so now what is 2n plus 2 factorial? So 2n plus 2 factorial looks like 2n plus 2 times 2n plus 1 times 2n times 2n minus 1, and then it's going to go all the way down to 3 times 2 times 1. So that's 2n plus 2 factorial. Okay, so as you can see, 2n plus 2 factorial is 2n plus 2 times 2n plus 1, and then this piece is just 2n factorial. Okay, so therefore I get that the absolute value, whoop, I want black, absolute value of AN plus 1 over AN is equal to, so the 2n plus 2 factorial becomes 2n plus 2 times 2n plus 1 divided by, oh, times 2n factorial divided by 2n factorial. So that's the first piece. That's just this. Okay, we still have n factorial. Get rid of that dot. Where's that dot? Get rid of this dot. Okay. Then that gets multiplied by n factorial over n plus 1 times n factorial. And then I get n factorial over n plus 1 times n factorial. So that is these two pieces. Okay, let's keep simplifying. So this is equal to, well, I can see that the two n factorials are going to drop out and the n factorials drop out. So now I get 2n plus 2 times 2n plus 1. And that is over n plus 1 times n plus 1. Okay, I can actually even simplify that more because this is 2 times n plus 1 times 2n plus 1 over n plus 1 times n plus 1. So I can divide out one of the n plus 1s. And so when I'm done, this becomes 2 times 2n plus 1 divided by n plus 1. Okay, finally. So rho is the limit as n approaches infinity of the absolute value of an plus 1 over an. And that is the limit as n approaches infinity of 2 times 2n plus 1 all over n plus 1. And that is 4. Oh boy, that is greater than 1. So hence the sum n equals 1 to infinity of 2n factorial over n factorial diverges. Okay, so all right, last test, number 12. This is the first time I have not gotten how many tests are there. Root test number 12, the last test. And actually, I don't generally teach them in this order. This is the order that the book is doing it in. I actually am not fond of this order, but it's okay. All right. Let summation an be a series. Compute rho is the limit as n approaches infinity of the nth root of the absolute value of an. So compute that. Same thing. If rho is equal to, if rho is greater, come on now, move. If rho is great, if less than 1, the series converges. If rho is greater than 1, the series diverges. If rho is equal to 1, the test is inconclusive. Okay. So example. Oh my God, I'm writing a sum. N equals 1 to infinity of, that's why I said this one is specifically suited for the root test, the root test. 2n plus 1 to the nth power. Okay, so now remember the nth root of an that is the same as saying the absolute value of an to the 1 over n. So either one of those, however you want to write it, whatever makes it best for you. I like it that way because now I know an is 1 over 2n plus 1 to the n. And the absolute value, this thing, that thing is the same as taking 1 over 2 to the n plus 1 raised to the nth power to the 1 over n power. Okay, so that's the same as 1 over 2n plus 1 to the nth power raised to the 1 over n power. So that just becomes 1 over 2n plus 1. Okay. So now rho, so limit as n approaches infinity of the nth root absolute value of an, but that's the limit as n approaches infinity of 1 over 2n minus 2n plus 1. And that's 0, which is less than 1. Series converges absolutely. Okay. Number 2. Summation n equals 1 to infinity of 4 to the n over 6n to the n. Okay, what do you, I'm gonna let y'all do that one on your own.
It diverges.
Okay, Eric, what's an?
So an so an is an's just 4n over 6n to the n, right?
It's 4 to the n over 6n to the n. Good. So now what's the nth root of an? If it's positive, I don't have to worry about absolute value. So I just need the nth root of an, or the absolute value of an. I'll write that even though it's fine. So that's what I need to find. What is that? It says take 4 to the n over 6n to the n and raise it to the 1 over n power. So that means that's 4 to the n to the 1 over n. So that's 4. And that's 6 to the 6n to the n to the 1 over n. So that's 6n. Okay, so that's what we get. So then rho is equal to the limit as n approaches infinity of 4 over 6n. And that's 0, which is less than 1. So the series converges absolutely. Now, I know some of you have zoned out when we got to series, but you can't zone out. You just can't. Okay. So here's some random series. Okay. Here's the first one. Summation n equals 1 to infinity of 3 to the n plus 2 over the log of n. Woo-wee. Okay. So let's do this test. So here we go. First, not a geometric series. Two, it's not a telescoping series. I could try the nth test of divergence. Is that the one I did next? I feel like I did the integral test next. Nope, I did do the nth test of divergence. I was right. Okay, so okay, we could try the nth test of divergence. So let's look at the nth term test of divergence. Okay, so if I look at the nth term test of divergence, I have the limit as n approaches infinity of 3 to the n plus 2 over the log of n, but that looks like infinity over infinity. So if I use L'Hopital's rule, I get 3, the limit as n approaches infinity, the derivative of 3 to the n plus 2. Well, the 3 squared I can take out. And the derivative of 3 to the n is 3 to the n natural log of 3. And the derivative of 1 over n, log n is 1 over n. So this is the limit as n approaches infinity of 9 times the natural log of 3 times n times 3 to the n. That looks like infinity. Ah, F-term test of divergent works. This diverges. It doesn't go to 0, so this series diverges. Okay. Let's look at another one. Summation. N equals one to infinity of -1 to the n plus 1 over n to the 1 plus n. Okay, anybody have an idea of what? Well, first off, it's an alternating series. So we can skip all of those first ones, and we can check, this is the alternating series test. Okay, so the alternating series test, that's a little tough. If I do A, my UN is 1 over n times n to the n. That's what this is. Okay. Okay, so I can check the alternating series test. And when I check the alternating series test, I can see that UN is greater than 0. And I can see that the limit as n approaches infinity of 1 over n to the n times n to the n, that limit is 0. So now I got to do part B. Part B is hard. I need to show that UN is bigger than UN plus 1. So I have to show 1 over n times n to the n plus 1, no, n to the n. Is bigger than 1 over n plus 1 times n plus 1 to the n plus 1. I'm not feeling that. So let's say I want to try the root test. Why do I want to try the root test? Because I have that power to the n there, and I'm thinking it might help me a little bit. So let's try it. So we have, this is the thought process. That's what I want you guys to see. So I have, for the root test, an is -1 to the n plus 1 over n to the 1 plus n. So now I need to find the nth root of that. The nth root of the absolute value of that, -1 to the n plus 1 over n. And I know that that's going to be times n to the n. So that is, I can get rid of the absolute value by making that a 1 over n times n to the n, all raised to the 1 over n power. So when I do that, I get 1 over, this gives me n to the 1 over n, And then that just gives me times n. Okay, I think I'm good now. So if I do rho is equal to the limit as n approaches infinity of the nth root of the absolute value of an, I'm using my root test. That's the limit as n approaches infinity of 1 over n to the 1 over n times n. Okay, does anybody know what this limit goes to? What does n to the 1 over n go to? Does n to the 1 over n go to? I think I got a taker.
I was thinking it was the negative nth to the square root, or not square root, but nth root of.
So n to the 1 over n, haha, goes to 1. Okay, we talked about that. So down here, I know this goes to 1 and the other thing goes to infinity. So this goes to 0, which is less than 1. So therefore, I can say the series converges absolutely. And when the series converges absolutely, that implies that it converges. Okay, that's it for today. I will see you guys on Thursday. I will start preparing your exams.